Hola, saludos. Mi nombre es Gabriel Fuentes. Soy doctor en operaciones marítimas y negocio marítimo. Actualmente soy profesor en la Escuela de Economía de Noruega y soy egresado de la Facultad de Ciencias Náuticas en la Universidad Marítima Internacional de Panamá. Eh, He tenido la solicitud de poder generar algún contenido que pueda servir de mentoría para sea estudiantes o académicos. Y he decidido que en esta ocasión tocaré algo de tema climático, del cambio climático y el ajuste de las operaciones, particularmente con un sentido hacia las operaciones marítimas y cómo son afectadas. En vez de hacerlo directamente desde esta plataforma, he decidido grabar una de mis clases de la semana pasada para así poder compartirles el ecosistema en donde me desenvuelvo también. Si tienen alguna pregunta o alguna duda, no duden en contactarme. Mi correo electrónico y mi información puede ser obtenida a través de la página web de la Escuela de Economía Noruega, Norwegian School of Economics, y estoy a su disposición para cualquier duda o consulta que tengan. Sin más, comparto el video a continuación.
So, not this one. All right. So, climate risk disruption and disruption in the maritime transport. Something that I have to disclose is like this is the first time that I teach this. And the reason is like this is a changing environment. This make significantly more change today than it would have made last year. And probably will make even more sense next year. So I decided to, at least for the course plan, to introduce something very timely, which is this aspect of climate risk. We're going to focus a lot on the operations part of the climate risk instead of the financial or the economics part. For today's lecture, these are the learning outcomes we're trying to cover upon. Particularly aspects related to consider economical, political, and ethical issues. This is relevant, at least from the case study perspective. This is a case study I wrote at the end of last year, which I have updated now. And the reason why I kept it is pretty much because it's still timely. This is a problem that still is going on. All right, so let's get into action. So particularly, what types of elements are affected by climate? I make a distinction between the four main ones, I would say, at least on my perspective. So you could have climate changing, or at least climate not being as usual, if affecting things such as the cargo itself, by the means of particularly some bulk cargoes, coal, grains, and iron ore, in the sense that they're quite sensitive, particularly with rain, right? Coal, for instance, cannot get wet or too wet because you can ignite in instantaneous combustion in the cargo itself. So actually, there's some coals that within the holds, they start getting, or they get a temperature so high that it may ignite the whole cargo by surrounding this ignition source. So coal is quite risky to have it wet for that reason. Naturally, you don't want to have a burning coal within a vessel while traveling. So a vessel may accept only a cargo if they can have a measure of how much wet or how much humidity the cargo has. So there's like a safe threshold they can carry, and at the same time, they keep monitoring on board the vessel for safety reasons. Another sensitive cargo, grains, for the obvious reasons that you don't want corn or soybeans being wet, because given that you are going to store them in a hole, which is a closed environment, it may generate humidity, and at the same time, it will create mold on it and have it not suitable for human consumption. There are some grains that you are not as concerned as other, particularly those grains that are used for feeding livestock, for instance. You will not be as careful as with a grain used to feed people. So another aspect is like it could be that with the water you introduce a fermentation process where the grain could not be used for the purpose it was harvested with. There, the other one that I recognize is iron ore, pretty much because iron ore becomes quite heavy when it gets wet, and it causes a very interesting and dangerous issue, which is that it creates some sort of, it makes the cargo quite fluid. if you check out on the construction of a bulk carrier, which regularly carries iron ore, most of the time they're not suited to carry liquids. They're suited to carry loose cargo, right? So if you put if you change the density of the cargo, the iron ore pretty much behaves as it was a type of liquid. The vessel itself has some levels of gravity, or centers of gravities, that allows the vessel to be stable. When you have a liquid moving in a hole, which is not open, it may create some forces on the sides. A strong force may make your vessel capsize if it's not properly controlled. So it's quite a dangerous situation in there. Did you get a question over there?
No, not anymore.
Okay. Yeah, no problem. The second category that I like putting in, and by the way, I'm taking it from my own experience, but I'm writing this as a chapter as we speak as well, a book chapter, which is called Climate Risk and Climate Futures. Ice by itself is that it gives you the problems of ice could cause your vessel to get trapped at port, meaning that you could be on areas where you enter without ice, and probably you had such a long delay that the access got completely frozen. And if your vessel is first not suited for ice navigation, and two, perhaps the ice is so thin that you cannot access or you cannot get out of the port, then you pretty much get liable for not having a due diligence before getting into that port. So you as a ship owner, I mean. So it pretty much falls on you. And at the same time, your vessel gets trapped and probably not available to a market with very high freight rates, which might be painful in terms of commercial management. Ice also causes higher fuel consumption, naturally, if you have to break ice. Some to the traditional resistances that a vessel has, meaning the waves, the currents, the wind, then you add an additional source of resistance, which is quite a solid resistance, right? So then you need fuel in order for you to break that resistance and propel the vessel. That implies additional fuel consumption. And there comes the risk of delay as well. When you're traveling on ice, most of the time you don't travel on a straight path. You pretty much either travel behind a icebreaker or you travel kind of zigzags trying to break the ice as you go. That may cause your vessel to get later than expected, which for commercial purposes implies that the vessel might not be able to reach a laycan. Ice by itself is not a deterrent or it's not an excuse for not arriving on time on the laycan. What could happen is like the charterer recognizing that there's a delay and that most probably they will not find a suitable replacement for your vessel, they would say, you know what, I can let you pass this one. You're going to arrive 3 days later. That's fine with me, pretty much because it will be very difficult for me as a charterer to find a replacement to you. So keep going, and whenever you arrive, we make it work, right? So the laycan is not such as strict. It can actually be lifted by the beneficiary of the laycan, which is the charterer, in order for allowing the vessel to arrive. It could be the case that the very hard-nosed charterer might identify like, okay, you know what, I don't care, my contract gives me the right to actually cancel this voyage, and perhaps order a vessel with a cheaper freight rate at the time. So this is quite a risky one to aim for. Another element that I do consider has a lot to do with climate, or climate not being as usual, because there's some debate on anthropogenic climate change we will discuss later, is the fact of heavy weather. Heavy weather connected to tropical cyclones and storms. So I actually like the term tropical cyclones because it identifies typhoons in the same category as hurricanes and other names that tropical cyclones are given depending on the area where they're happening. So hurricanes happens in the Caribbean, typhoons happens in Asia, for instance. So in here you got tropical cyclones and storms. The effect of tropical cyclones is pretty much on more fuel consumption, naturally. Once again, you have an increase in resistance of the elements to your vessel, therefore you need more energy to break that resistance and propel the vessel. Another aspect is of port closure, and particularly on the US Gulf, this is quite sensitive. In hurricane periods, most of the time you see this curvature of hurricanes actually making a turn in the US Gulf. The US Gulf hosts some of the most important grain ports in the world, at least for the dry bulk sector. And having a port closure may pretty much hampers your options to, in a hot market, be available to the market back again. Fortunately, for contractor reasons, and then you realize I did not put risk of delay, acts of God due to heavy weather is actually one option for you to actually deter the times of arrival. Finally, and but not least important, canal and rivers. With low levels, or at least with low rainfall, you may expect some rivers and some lakes to get drier. That may limit the capacities of some vessels to allocate cargo. Remember that I mentioned that one of the limitations of cargo, how much cargo they can load, or vessels of how much cargo they could load, is pretty much on that level where they will not be, where they will actually deviate from touching to the bottom. So in the safety reason, that means that any restriction on draft will limit your vessel capability of storing cargo. And at the same time, some of the contracts, remember, are charged in a dollar per ton basis. So your motivation is to load as much as possible. Given the limitation, that means that you will have less dollar per ton. No, you will have the same dollar per tons, but you will have less tons, meaning you will have overall less freight. And we're going to touch examples of each of these cases briefly. So why do I focus so much in the bulk cargo? Because from my perspective, the bulk cargo is the most exposed to the weather elements. If you compare it to other types of cargo, namely oil, for instance, given that your cargo is stored in tanks at shore and is stored in a tank on board a vessel, this cargo is never exposed to the elements. Unless there's some restriction due to ice or restriction due to weather, your cargo will not suffer the hampers of having rain on top of it, such as the bulk cargo. So here goes an example of a Google Earth image of a port in Argentina. This port is called Rosario. That is a port, and if you identify, it's within a river. Look how dark it is. And it's a port where the cargo is actually stored at the open space. It's not stored within silos, which means that in periods of heavy rain, you will not like to have that cargo out there. So then you have it transported by ways of belts up to the vessel. And this is pretty much how the operation looks like. You have a belt coming all the way up on top of the hulls, and then the belts, or at least this part of the belt, pretty much moves sideways and fills in the holes in there. So what you will expect with this type of cargo is that if it starts raining, you have to stop your operation and close your holes and wait until it stops raining so you can keep going. So naturally, you might expect, like in periods where you have like half rain, half dry period, vessels may take a long time in there waiting to conclude their cargo operations, which once again represent a risk for the ship owner, because in a hot market, the vessel is not out there ready for a new cargo, to negotiate a new cargo. So here goes an example of that same port in the Paraná River, San Martin. Or it's a port very close by to Rosario. And you see some sort of seasonality, one happening somewhere in February, and then again in February, and it's pretty much aligned with some rain period in the area. So you may expect the shipments from goods actually reduces quite a lot, and that's pretty much driven by that. You got a progressive decline in here, and then like a full drop, and then a spike pretty much after heavy rain period ends. But rain is not always a bad news for shipping, at least the bulk commodities, pretty much because of this case that I'm telling you, that the river levels may also be harmed, or the draft of the vessel may be harmed if it doesn't rain enough in some areas. Paraná River is like the best example of contrast in here. It's a problem if it rains too much, it's a problem if it doesn't rain. So they are quite sensitive to that aspect, and most importantly, one of the most important soybean export ports in the world. So that creates some sort of ripple effects in the economy or within that market as they are affected. Here goes another example. This is the port of Port Hedland. That's in Australia, Western Australia. So this is like the base port for a company called Rio Tinto, which is a mining company exporting iron ore. And this is pretty much how it looks like. If you identify the vegetation that doesn't exist, that implies that this is quite a dry area. So it is particularly a good port for only the purpose of exporting iron ore, because first of all, they can store it on open spaces. You don't want iron ore to be stored on silos or such, pretty much because you need to build the infrastructure and silos are quite restrictive. If you have it on an open space, check out the piles of iron ore in here. then you can accommodate more iron ore without any issues, and then you can avoid some sorts of issues related to double handling of the cargo and such. So same system, you have like piles of iron ore connected by either rail, or by belts, and thereafter connecting to the port. Is this fertile? No, this is iron ore. Through the ports, through the belts, and then being stored into the vessel. So let's put an example in here, or let's ask some questions. What type of vessels are we seeing in here, for instance? So probably it's a bit small from there. You can see it from your screen, but at least you see 1, 2, 3, 4, 5, 6, 7, 8, 9 holes. Yes? It's a capsized vessel. You have 9 holes and no crane on top of the vessel. One of the examples where we saw before, we had the Handymax vessel with cranes on it, pretty much because they might accommodate on ports where they actually need to use their cranes. This type of vessel tends to come to these types of facilities where everything is self-loaded via conveyor belts. Port Hedland, a nice place. I went several times there. Quite isolated, but nice. Is there anybody from Australia here? No? So here goes the aspects of the tropical phenomena. I like to call tropical phenomena to anything that happens between the tropics of Cancer and Capricorn. That's between 26 north and 26 south. Anything that happens beyond that is extratropical, right? So it's pretty much this belt over here. So there's a lot of climate activity happening in this area pretty much because of the water temperatures of the oceans. The water temperature of the ocean is the feeding ground for storms and hurricanes. For instance, you see like very common patterns of, and let's put the case of the Caribbean. You have storms actually starting somewhere close to Cape Verde, west of Africa, making this type of shift to the left, and then making this type of turn. The reason why hurricanes, and then you identify that not many hurricanes touches land, is because hurricanes feeds on water, on hot, warm water. So therefore you see this kind of pattern, which is actually good for the perspective of a navigator or somebody planning to send a vessel to a port. Because you can, with some sort of certainty, you can forecast what might be the pattern of hurricanes, so to speak. So for instance, if you have a hurricane here, it's very unlikely that that hurricane crosses land because it doesn't feed on land, it feeds on warm water. So therefore you might be planning with the hurricane cold, pass the canal perhaps, and trade on the other side of the continent. Important things of this is like these are quite seasonal. These events are quite seasonal and has to do with the water temperatures, of course. And they happen on several times of the year. For instance, the hurricanes, that's the name that is given to tropical cyclones in the Caribbean, happens between the Caribbean and the North Atlantic. They don't go further than UK, for instance. And they happen somewhere between June and September. So that's what people call as the hurricane season. So if you're a trader or somebody trading with a vessel that actually has routes that have been affected on this, you have to have due consideration that you might have the risk of closure on ports, you might have the risk of higher fuel consumption, etc., such as we discussed before. In the Australia area, funny enough, given due to the rotating force of the country, of the world, hurricanes tend to shift on the contrary direction than hurricanes in the north side. So pretty much they make turns like this, coming up the way to this area in some periods. And once again, not passing masses of land. So you may expect at least ports like as Port Hedland, which is somewhere here, might be somehow affected by hurricanes if you are trading iron ore from the Rio Tinto terminals. And you got periods for that. You may expect it to happen, or at least these things to happen somewhere between October, November, February, and March. And you also have the option that you may face heavy rain or heavy storms by trading in the Southwest Indian Ocean, so somewhere here, where typhoons can also generate. There's also a very heavy area, which is this area most of the time facing Japan and facing the South China Sea, somewhere here, which also needs to be taken into account. Right, so I place a link. We can actually check it together, where we can see something about atmospheric pressure. At least for a navigator, this is important, and perhaps this is a piece of knowledge that you as a commercial operator should know as well. A good way to monitor whether a system is developing, namely a hurricane or a tropical cyclone or a storm, is by means of checking out your atmospheric pressure maps. So in here we have a map of the world and atmospheric pressure all over the place. Just for your reference, here is Norway. We have a high pressure nowadays. That's why we have fair weather. That's why we have sun. And the things that happen in here is like your problematic areas are going to be the areas of low pressure. The lower the pressure, the finer the isobars, which is like this space between pressure areas. And that creates, on a difference of pressure, that creates strong winds. As the system gets stronger and stronger and faster, water is also moved out of the system and it's moved away to the high pressure areas, and that creates even faster winds. And that's why you see these rotating things. Eventually, this gets so fast that it becomes a hurricane. Okay? For the bad luck of Norway, we tend to live in the intersection of these high areas and low areas. So this tends to move somewhere here most of the time. And this intersection pretty much brings all the humidity of the high areas into this low area. And most of the clouds happens to be in the intersection of these two areas. Most of the time, this happens to be on top of Bergen. So that's why we have so much rain in here. All right? There's an argument for that as well. Remember that the Gulf current, a current that generates in the US Gulf or such, ends up in Norway with warm water. I told you already that storms and hurricanes feeds on warm water. Okay? Pretty much they shift on top of warm currents. So that's why we have so much rain in here. For lucky us, we have a huge high pressure area, which aligns me to say like probably we are going to have fair weather at least for a week. Don't call me back on Monday if it starts raining power, because this can shift quite rapidly. But in any case, I may have a prospects on it because this intersection area is quite far away from Bergen, right? So you as a navigator or you as a commercial operator, you will start checking this out. You might be concerned, for instance, if you're coming from Gibraltar Strait to Quebec, pretty much on this development. You have 989 hectopascals in the center of this system, which pretty much tells you something about the wind. A lot of wind happens, and wind creates a lot of waves or high waves. So you may expect that if you sail through that system, you will use a lot of fuel. Commercial, or at least technology development companies related to shipping operations, they tend to use this information in order to do something what is called weather routing, which is pretty much based on forecasts of these evolutions telling you where your vessel actually have to sail to take the best advantage of the sea. So it might be the case that they might send you somewhere like here and try to deviate in here as much as possible, or perhaps going a bit north because the wind is blowing that direction, and then you take advantage of the currents and the wind. Right? So there's like, this is also the intersection of mathematical programming as well, used for maritime operations. Right. So.
Muchas gracias por su atención. Con este segmento del curso presenté alguna información relevante a los efectos del clima en las operaciones marítimas y en el desarrollo del negocio marítimo. Obviamente quedan algunas secciones por fuera, información como los efectos del cambio climático sobre los niveles de los lagos en Panamá, el efecto del cambio climático en el río Paraná en Argentina y el uso de instrumentos financieros sobre el clima para poder contrarrestar los efectos operativos del cambio climático en las operaciones. Sin más, espero haya sido de su agrado y nos vemos en alguna otra ocasión.